Hello everyone, I am Khushwant Maurya and this is my B.Tech 4th semester project, a digital clock. What makes this project special is that I didn't use ready-made displays. I made the entire 7-segment display myself using 87 LEDs. I have used the puff board for making the display. In this video, I will show you how it works and how I built and what I have learned during the process. The digital clock shows the current time in hours, minutes, and there is also a blinking LED. There are three LEDs that are blinking. The brain of the clock is an Arduino Nano, which is this one, and it gets the correct time from DS3231 RTC module, which is very accurate and has a battery, so it remembers the time even when the power is off. To make it more interactive, I also added buttons to set the time like minutes and the hours, and there is a mode button which is adjustable. First we press it, and then if we want the hour to set up, then we click on this, we press this button. If we want the minute to be changed, then we press this minute push button. So here is a switch which will be turning on my whole project. From this 3.7 volt battery, the power is going in all the components which are present on my project. So let me switch on the supply. So from here I can switch it on. Now let's talk about the most interesting part, the display, which is present over here. I made 4-digit 7-segment LED completely by hand. Each digit had 7 segments. You can count also 1, 2, 3, 4, 5, 6, 7. There are 7 displays. And each segment has 3 red LEDs, and so there are 84 LEDs in total for a digits. I also added 3 extra LEDs which are blinking every second, present in between the minutes and hours. So this display is built on the puff board using the jumper wires. It's common anode display, which means it is a type of common anode display, which means the positive ends of all the LEDs are connected together, and we control the negative cathode side using the Arduino. The negative side of the LEDs, that is a 7-segment display, have been using the Arduino pins that are named as a D13, D12, D11, D10, like this. There are D0 till means there are total 13 digital pins present in this Arduino Nano. So let's continue about explanation about the project. Let's talk about the designing and the making of the PCB. To make the circuit neat and strong, I designed a custom PCB using EasyEDA software. After designing, I printed the layout on a glossy paper using laser printer. Then I transferred the toner onto it and the copper board using a hot iron. Next, I dipped the board into the ferric chloride solution to remove the unwanted copper and leave only the circuit traces. After that, I drilled the holes and soldered all the components. Arduino Nano RTC. This is Arduino Nano RTC module, and there are some resistors which I have required, and the headers and the wires. And some, you can say, the buttons, push buttons, and this switch and this connector. And already I have made the display using the puff board, so there I have used the wires. It was a very long process, but it gave me a head-on experience in electronics. Connecting the 87 LEDs was very careful job. I used the thin wires to connect each segment to the Arduino through current limiting resistors. Each digit is controlled using multiplexing, which means only one digit is turned on at a time, but it switches between them very fast, so it looks like all are on at once. Actually, there is in very nanoseconds. One segment is turning on and that one is getting off, and the next segment is turning on, that one is getting off, and previous one is getting off. Like this, there is a continuation in turning on and off, on and off, on and off. But this process happens very fast, very fast, so our eyes cannot detect that. That is what happens in this multiplexing concept. Now let me talk about the coding part, that is a software part where I have built a code. I wrote the code in Arduino IDE. The Arduino reads the time from the DS3231 module and displays it on handmade LED segments. The RTC keeps the time running accurately even when the power is off. Suppose I am turning off this power from the switch. So in the background, this RTC module 32 DS3231 is calculating the time in its background. There is a coin cell behind this RTC module, so that coin cell have a very long life since the power is off, so that this RTC module saving the data from that LED, and it is working in background. So whenever I will turn on the supplies again, there you can see the time That is a lifetime, you can say. Now it is 19. I think about some seconds, 40 or 15 seconds have been passed, so that has been calculated in this, like this only. So next, there are total 3 push buttons on the board. One for setting the hour, which is this one for setting the minute, which is this one, and one for adjusting mode, that is you can call as a setting mode. When I press the button, the clock enters the setup mode and lets me to adjust the time easily. If I will keep pressing it on, then I can adjust hours. Suppose from this thumb I am pressing this and I am pressing minute 1, you can see that it's 7:23 now, so we have set the minute time now. I used 3.7 volt battery to power the circuit. There is also connector that lets me to remove or change the power easily. This is a connector. I can remove it and I can also change the power. Suppose I want here 5 volt battery, then I can put 5 volt battery also. All components including the displays are connected cleanly on the PCB. This project was full of challenges. Soldering 87 LEDs took time and patience. Despite designing the circuit to work perfectly and custom displays was tricky. Making the PCB home taught me how to etch, drill and solder carefully. But I learned a lot about Arduino programming, RTC usage and the multiplexing and custom hardware design. This digital clock is not just a display project. It's full of package, hardware and the software and the creativity. I really enjoyed building it and it helped me to grow my skills in electronics. Thank you for watching my project once again. I am Khushwant Maurya. See you soon.